Okay, so today we are using tables to find rate of change. Okay, so rate of change, we're comparing two quantities and how one affects the other. So how one number affects another number, okay? So, number one, the table shows Stephanie's height at ages 9 and 12. What is the change in Stephanie's height from ages 9 to 12? Okay, so how is it changing? Her height.
It goes up by 6 inches.
It goes up by 6 inches, okay? So it's increasing. It's positive. So 6 inches. Okay, so she grows 6 inches. All right, number two, over what number of years did the change take place?
3.
Okay, 3 years. Over 3 years. Okay, that's how long it took. So write a rate that compares the change in Stephanie's height to the change in age. Express your answer as a unit rate and explain its meaning. Okay, so what is affecting what? Is her age affecting her height, or is her height affecting her age? Age is affecting her height, okay? So on the bottom, it's always time, okay? So 3 years. That's what's affecting her height. So on the top, 6 inches. Okay. Can that be reduced? Can we simplify that? Okay, to what?
2 over 1.
2 over 1.
Just equals 2.
Okay. So 2 inches in 1 year. Okay. So the rate of change, oops, is 2 inches per year. Okay? All right. So define rate of change. Okay? So I'm going to put down what I've said. So how one number affects another number. Okay. Another thing I'm going to write. It's a steady change within numbers. Okay, so what's another word for steady? So it kind of sounds like that, right? Consistent, okay? Consistent. Okay? So it's a consistent number. Okay, number 2. The table shows the amount of money a booster club made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. Okay, so this club has a fundraiser, and the kids all started before a parent got there, okay? So they didn't know how much they were supposed to charge, so they just started accepting whatever money the people were giving them. So when the parent got there, they had already washed 5 cars, okay? And they had made $40. And then 5 cars later, they had $80. So she's trying to decide, okay, how much are we charging per car? Okay, so that's what we're going to figure out right now. So from 40 to 80, how is that changing? Goes up 40, okay, so plus 40. What about 80 to 120? Plus 40. Okay, and over here, from 120 to 160. Plus 40. Is it pretty consistent? Is it steady? Okay. Now let's go over to this side. So number of what? Number of, what's that column?
Cars.
Number of cars washed, okay? So from 5 to 10. Subtracting 5? Plus 5. That's a plus sign. Okay. From 10 to 15.
Plus 5.
And from 15 to 20?
Plus 5.
Is it consistent?
Yes.
Is it steady?
Yes.
Okay. So now let's figure out the overall rate of change. Okay. So what here, let's think about it. What is affecting what? Is the number of cars affecting how much money they have? Or is the number of money they have affecting how many cars they've washed? Okay. So again, is the number of cars affecting how much money they have?
Yes.
Okay. So that's so on the bottom we're going to have cars. So 5 cars. Okay. And what goes on the top? Money. Okay, so $40. Can that be reduced
Yes.
to what? 8 over 1. Okay, so how much are they charging for each car?
$8.
$8. Okay. So each car costs $8 to wash. Any questions so far? Yeah.
So, in other words, would you put the independent way in the denominator and the dependent?
Yeah. Okay. So independent variable on the bottom, dependent on the top. In other words, y over x. That looks like an x over an x, but that's a y. Okay. Y over x. Okay. Number 3, the graph represents the distance traveled while driving on a highway. Use the graph to find the rate of change in miles per hour. Okay, so let's make an XY table. Okay. Okay, so what's my first x value? Okay, 1. And what's the y value for that 1?
60.
Okay, and my second x value? Over here? My second x value?
2.
2. And my second y value?
120.
120. Okay, over here, what's my third x value?
3.
3. And my third y value?
180.
180. Okay, girls in the front. How is my y changing? Over in the corner. How is the y changing?
By 60.
By 60. Okay, is it increasing or decreasing?
Increasing.
Increasing, so plus 60. Is it the same for 120 to 180?
Yeah.
Okay. Again, steady, consistent. X, how is that changing?
Plus 1.
Plus 1. 2 to 3? Plus 1. Okay, so like we said on that last slide, okay, y over x. Okay, so what's my change in y? How is my y changing? Over here. How is my y changing?
By 6.
60, okay. And how is my x changing? 1. Okay, and what are we talking about? Miles per hour, okay? So miles on top, hour, time is always on the bottom, okay? Miles per hour. Okay? Any questions? Okay, let's move to the next one. All right, at 1 o'clock, the water level in a pool is 13 inches. At 2:30, the water level is 28 inches. What is the rate of change? Okay, so let's make an XY table again. Okay. So, X value. What's an X value? X is always what? Or time is always what? On the bottom. And on the bottom is always X. So my first time is going to be 1, okay? And then 2.5. Okay, what's my Y value for 1? Over here. My Y value for 1. 13. Okay. And over here. What's my Y value for 2.5? My Y value for 2.5. 28. Okay, so how is the Y changing? How are my Y values changing?
Increasing by 14.
Increasing by what?
15.
15, okay. What about my X values? By 1.5. Okay, and again, Y over X. Okay, so 15 over 1.5. What's 15 divided by 1.5? 10. 10 what? 10 inches per hour. Okay, so water level increases 10 inches per hour. Okay? Okay, number 5. So I want you to fill out the X column. Okay, -2, -1, 0, 1, and 2. Okay, and what function are we evaluating? 2x minus 1. Okay, so let's start plugging numbers in. Okay, so start listing numbers in order. What did you guys get for the first one? What? 5? -5? And then what? -3? -1? 1? And 3. Okay, so how are my Y values changing? 2, is it subtracting by 2? It's adding by 2. Okay. We're adding by 2 on each one. What about my X values? We're adding 1. Okay. So is it X over Y or is it Y over X? Rate of change. Y over X. Okay, so my change in Y is 2, positive 2, and my change in X is a positive 1. So, my rate of change is 2.
Is there any symbol that you want us to put, like
Not f of x equals 2.
F of X doesn't equal 2. F of X equals 2x minus 1. Okay. All right. So, fill out the same thing, -2, -1, 0, 1, and 2 for 6 and 7, okay? And then you're gonna evaluate those. So I want you guys to fill out the X column.